we're going to look at the change of variables in partial derivatives. Alright? Now, the argument is this. Suppose you have it that z is a function of x and y. But then x is a function of something else. Let's say t. Y is also a function of t. Alright? Now, what you want is the partial derivative of z with respect to t. How do you deal with that? Alright, let us see how that goes. Now we write the differential of z and say a small change in z is equal to the partial of z with respect to x times a small change in x plus the partial of z with respect to y times a small change in y. You remember that formula there? Now, suppose we divide by a small change in t. What would that? Let's see. A small change in z. Let's write everything as it is first. Is equal to the partial derivative of the z with respect to x times a small change in x plus the partial derivative of z with respect to y times a small change in y. We divide by a small change in t, so divide here, and we divide here. Good. Now, suppose the change in t tends to 0. Then this will become this. The small change in t, or del t, will become delta t, which is the derivative. So what we have then is that the partial derivative of z with respect to t is equal to the partial derivative of x with respect to z with respect to x times the partial derivative of x with respect to t plus the partial derivative of z with respect to y times the partial derivative of y with respect to t. And if you notice, it's like we have delta z over delta t, right? So much like that. If we cancel these, and we have delta z over delta t here, see that? Plus, can cancel delta y and have delta z over delta t here. So you see that it would work out. So that's the formula that we are going to be using in determining this change of variables. So we look at some examples in the upcoming videos. I'll see you then.